In this video, we're going to be going over some practice problems talking about Lewis dot structures and molecular shapes. So this should be a video to check your work. So you guys should go ahead and do this on your own if you have not already, and then go through these to check your answers, and then watch if you have questions and stuff. So our first molecule we have here, we have C2H2. So let's first find our total number of valence electrons. Carbon has 4 valence electrons each, and then hydrogen has 1 valence electron each. So our total number of valence electrons is going to be 4 plus 4 plus 1 plus 1, which equals 10. Okay, so our Lewis dot structure, I'll just be going straight to the answer for you guys. We have our carbon bond connected in the middle. As you'll notice, this does not fulfill the octets for the carbon, so we know we need to have a triple bond here. So this is going to be our Lewis dot structure. Everything has its octet rule and or 2 electrons for hydrogen. And then we need to look at the molecular shape for this molecule. So our molecular shape drawn in 3D is actually just going to be the same thing because these are all linear. So both carbons for this molecule are linear. The angle is 180 degrees as we're given. Okay, next we have we have CHF3 is our formula based off of the molecule that we're shown here. We have 7 valence electrons for each fluorine. All right, let's start with carbon. So carbon has 4 valence electrons, hydrogen has 1, and then we have 3 fluorines. So we'll have 7 plus 7 plus 7, which equals 26 electrons. Okay, now we need to draw it in the correct shape. We have our Lewis dot structure here. Now we need the molecular shape. So we have one central atom with 4 atom groups around it. So we're going to need a tetrahedral shape. To draw that, I'm going to go ahead and leave my lone pairs out of this one. I'm going to draw my carbon with my 4 groups around it in my tetrahedral shape. And then we have our 3 fluorines and 1 hydrogen. So it doesn't matter exactly where each one of these atoms are. If the hydrogen's in a different place, that is still correct. And then our angle for a tetrahedron is 109 degrees. Next, we have SeCl2, total number of valence electrons. Selenium is under sulfur, so it's going to be 6 electrons plus 7 for chlorine, and then we have 2 chlorines, so 2 7s. That equals 20. Okay, and then we're going to draw our Lewis dot structure. So selenium will be in the middle, chlorine on each side, and fill in our lone pairs. Great. Okay, so we have a central atom that has 2 lone pairs and 2 atom groups. So we'll overall have a bent shape. We'll just draw it like that. So again, you can draw in the lone pairs. You don't have to, but I kind of like to. And then we'll have an angle of less than 109 degrees because we have lone pairs on there that are bigger than the chlorines. Okay, we have this molecule here. We already have it drawn in the correct shape. So let's go ahead and describe that shape real quick. It is trigonal planar. I know because carbon in the middle does not have any lone pairs. It has its full octet without lone pairs. So it's going to be a central atom with 3 groups around it. That has a 120 degree angle. Okay, so our Lewis dot structure, we can go back. We're going to have carbon double bond to oxygen, fill in all of our lone pairs in here. So if we count everything, we have 1, 2, 3, 4, 5, 6, 7, 8 lone pairs. So we have 16 electrons in lone pairs. And then we have 4 covalent bonds, which is 8 electrons, which when you add all of that up, you get 24 valence electrons. So that's one good way to check. And then lastly, we need to put our formula in. So we have COCl2. Okay, great job so far, guys. Our last one is going to be O3, which is the name ozone. It's the molecule we have in our ozone layer out in space. Okay, so we have O3. We already know that we are told that we have 18 valence electrons in this molecule, which we could double check just by having 6 valence electrons for each oxygen times 3. Our shape for this molecule, our lowest dot structure, is a little bit funkier than you'd probably expect. We have oxygen, 3 oxygens in a row. One side is going to have a double bond. One side is not. Then we have a lone pair on the central oxygen. Okay, so this is a little bit weird. We didn't talk necessarily about this structure because we have 3 different groups around the central atom, and one of them is going to be a lone pair. So we take our trigonal planar shape and we delete one of the sides or delete one of the atoms. So we will then end up with a bent shape. So I just like that one lone pair in there just to make sure I describe the shape correctly. So it will still be called bent. However, instead of having less than 109-degree angle, we actually have less than 120 degree because it comes from that trigonal planar shape originally. Those are your answers for your molecular shapes practice. Hope you guys did well. And again, if you need any help, please don't hesitate to let me know. Have a good night, y'all.